Okay, so before we begin, I just want to emphasize that hopefully you're a master when it comes to common factoring, factoring by grouping, and factoring simple trinomials. In this lesson, we are going to factor complex trinomials. So what is a complex trinomial? It's basically like a simple trinomial, but the coefficient of the x squared term is not 1. It could be 2, 3, 4, I don't know, any number that's not 1. Now, there are actually two ways we are going to look at when it comes to factoring complex trinomials, okay? One of the ways is called decomposition, and the other one is, there's different names people have for it, but I just call it guessing and checking, because that's what you're really doing. I'll teach you or show you decomposition, but I will not recommend it, okay? Whenever you see me do the homework questions, or whenever I take up questions later on, whenever I see a complex trinomial, I never use decomposition. Why not? It's slow, it's cumbersome, it takes too much time, it's lots of steps. The only reason I like it is because I guess it works. It is a consistent, very formulaic approach. But this other method, the guessing and checking, is the preferred method in grade 11 and 12 because you will have to for complex trinomials, and it should not take you more than 10 seconds to factor a complex trinomial. And you cannot do it in under 10 seconds when you use this method of decomposition. It takes way too long. Okay, so you know what? Without further ado, let's just show you the method of decomposition. So, 2x squared plus 5x plus 2. So this is clearly a complex trinomial because the coefficient of the x squared term is 2, it's not 1. And I can't deal with it. I can't there's no common factor of 2. So how does decomposition work? So the first step is you find two values and multiply to the product of a and c, or product of AC, and add to b. So AC in this case is 4. So what multiplies to 4 and adds to 5? Well, 4 has 4 and 1. So hopefully you know that the two numbers are 4 and 1. And this is where the name decomposition comes from. You decompose, you break apart that middle term using the number you said. So 4 and 1, so 5x becomes 4x plus 1x. Okay, now what do? You factor by grouping. You can put a 1 here if you want. So now, hopefully you didn't forget, x plus 2 is a common factor. I know it's a binomial, but it's a common factor. So x plus 2 is gone, so then you're left with 2x plus 1. So there you go. That's factoring by decomposition. There is no way you can do that in under 10 seconds. Because even though you might know the numbers that multiply to 4 and add to 5 very, very quickly, writing all those steps, just factoring by grouping, is going to take you forever. Okay, so let's try to decompose this once again. What multiplies to negative 6, because AC, in this case, 3 times negative 2 is negative 6. What multiplies to negative 6 and adds to negative 5? Because once I find those two numbers, I'm going to decompose that middle term into, I'm going to decompose that middle term, and then I can factor by grouping. Okay, so once again, what multiplies to negative 6 and adds to negative 5? Oh yeah, negative 6 and 1. So negative 6x plus 1x. See? This, I know we broke it apart, but it's really the same thing. Negative 6x plus x is negative 5x. Why do you want to break it apart? Because now you'll be able to factor by grouping. So 3x. Once again, I'm going to put that 1 there just to help you out. That's real ugly. Let's fix that. And then x minus 2 is a common factor. It's just a coincidence, by the way. X plus 2 and x minus 2 for the first and second example. Alright, that's it. That's factoring by decomposition. So I think the hardest step is finding the two numbers. And then once you're there, you decompose a middle term, and then you factor by grouping. So if you haven't mastered your ability to factor by grouping, then the method of decomposition will be pretty bad. Okay, so like I said, I really don't recommend this technique. I will show you, I will teach it to you, but I highly do not recommend it. In fact, since I'm on this story, what not to do, some students, when they see simple trinomials, they also factor by decomposition. So what multiplies to 6 and adds to 5? So hopefully you just say 2 and 3. But some students, they factor simple trinomials using decomposition. And you can do it. You can factor simple trinomials by decomposition, but that's pretty silly, to be honest with you. So please don't do it, okay? Because I see this on tests all the time. I don't know why, but students factor simple trinomials by decomposition. So that partially makes me regret teaching decomposition, but anyways, it's one of the ways to do it. Okay, so on to what I really want you to do. So with this method of guessing, what we're going to do is start off with a diagram to help us understand how it works. Usually when we write the factors of the binomial, we write them side by side. But for this technique, we are actually going to stack the factors on top of each other like this. Okay, so I don't know what the binomials are, but let's say there's a mystery term here, mystery term there, there, and there. Okay, so we're also going to draw these like hot dog looking shapes. But what I really want to show you here is that you want to connect these terms, the diagonals, okay? Because these diagonals, basically they're telling us that we want to multiply whatever these terms are, whatever you choose to put here, we want to multiply these terms, okay? And then we're going to see what do we do from after we multiply, where do we go from there? So you know what? Let's factor this complex trinomial here. So I'm going to stack the binomials on top of each other. Okay, so let's see. The first term of the trinomial is 2x squared. That's perfect. 2x squared, beautiful. 2x and x. What else can it be? It can't be anything else. You know why? Because 2 is a beautiful number. 2 is prime. Excuse me, in fact, 3 here, we're trying to make a -3 here. Well, how do you make a -3? You put the numbers for the second term of the binomial, they're going to multiply to -3. So 3 is beautiful because 3 is also a prime number. Now, the question is, where do you put the 3? That has a huge impact. So I'm going to put the 3 down here and the 1 up here. And I'm going to draw those diagonals. So like I said, I'm going to multiply them, right? 2x times 3 will give me 6x. 1 times x is x. Well, be careful. This did not multiply to 3. This multiplies to, this does not multiply to -3. This multiplies to +3. So if I want to multiply to -3, one of these has to be negative. The question is which one? Well, here's my hint. We didn't talk about the middle term yet. We said that the first term of the binomials have to multiply to 2x squared. The last term of the binomials have to multiply to -3. But what about the middle term? Well, just like when we learn about expanding and simplifying, you have to simplify to -5x. Well, I've made x and 6x. Well, x and 6x won't simplify to -5x unless it was x and -6x. If it was x and -6x, it simplifies to -5x. So since you want -6x, guess what? You want -3 here and +1 here. So there you go. It works out. This will give you 2x squared. This will give you -3. The diagonals will simplify to -5x. You're basically putting terms here until it works out. That's the guessing element of it. But once you do this enough times, you'll realize you're not really guessing. Okay, so let's go back to our diagram up top. These were side by side. These were stacked on top of each other. But if you can look, this term and this term, is really this term and this term. And this term and this term is really these two terms. So what you're really doing is what we did in the first lesson of this unit. This is O, outside terms and inside terms. And you have to make sure the outside terms and the inside terms simplify to the middle term of the trinomial. If it doesn't simplify to the middle term of the trinomial, guess what? Your binomials are incorrect. Okay? So, let's look at our next complex trinomial here. We have 6x squared minus 5x minus 1. Now, 6x squared is not as friendly as 2x squared in our first example. 6 is not a prime number. So 6x squared, you could do 6x and 1x or 2x and 3x. Now I'm going to put 6x and 1x. And I can tell you that's a bad idea right away. Why is it a bad idea? Because I'm trying to make negative 5x, right? Let's put the negative 1 here. They both have negative 1 in fact, because I have to multiply positive 1 and add to negative 5. So let's look at our diagonals. I'm not even going to draw the hot dogs. I'm just going to negative 6x, negative. Yep, doesn't simplify to negative 7x, right? Sorry, it doesn't simplify to negative 5x. It simplifies to negative 7x. So guess what? These binomials, when I expand and simplify them, it will not make this trinomial. Okay? It will make 6x squared minus 7x plus 1. But I don't want 6x squared minus 7x plus 1. I want 6x squared minus 5x plus 1. So let's try again. Instead of 6x and 1x, I'm going to do 2x and 3x. And then minus 1. Yes. This will give me minus 3x, minus 2x, bam, 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 minus 5x. So 2x minus 1, 3x minus 1. Beautiful. So we have two techniques here. I just want to mention the rest of this page. We are proving how the method of decomposition works, because I kind of just threw it at you as I multiply the AC and adds to B, and it works, but the explanation of why it works is here. I don't want to spend more time on it because, to be honest with you, I don't want you to do use this technique. Okay, I really want to emphasize how beautiful this technique, this guessing and checking technique is. Okay, in fact, when a student is able to do this very quickly, they've shown me that their number sense is very, very strong. Okay. So I'm gonna do a few more examples. Some of them are being straight from the homework. So let's see this one. This one's pretty easy. 2x squared plus 5x plus 2. I think that's actually on the first page. Yes, it is. Perfect. So this is on the first page, and we did it by decomposition on the first page. But here I'm going to use the guessing and checking way. So this is actually a great example to show you how it's actually not really guessing. 2x squared, so I put 2x and x. Now for here, I have to choose. 2 is prime, beautiful, but do I put the 2 in the first factor or the second factor? Now if you thought of putting the 2 here and the 1 here, that would be very silly. That would be very, very silly, because look, you'll make the factor 2x plus 2. 2x plus 2, you have a common factor of 2 here. Where's your common factor of 2 over here? You can't introduce a common factor of 2 because there's none to begin with here, right? So since that is the case, then it would be a horrible guess to put the 2 with the first factor. So it has to be the other way around. It has to be 1 and 2 like that. And let's check. 2x and 2 is 4x, 1x, 4x plus 1x is 5x. Over time, you won't be writing things down. You'll write less and less and less. So you write 2x plus 1 and 2x plus, x plus 2. Okay, that simplifies. Let's do 6x squared. We already did that one. Let's do the other example that we did on the first page. 3x squared minus 5x minus 2. So I'll show you how I factor these. In fact, I don't even draw the diagram, so I'll show you what I do. So I know 3 is a prime, so it has to be 3x and x. 2 is also prime, so where do I put the 2? Where do I put the 1? I'm going to put the 2 here and the 1 here. Why do I put the 2 there and the 1 there? Because I want to make the 6x and 1x, that's going to make my 5. So I do negative 6 plus 1, that's negative 5. So over time, that's how it's going to look like. You'll get very, very comfortable, and you're really not guessing. It's based on a intuitive feel for the numbers. We'll do one more just for good measure. I'll do one that's not prime. So 6x squared plus 13x plus 6. Let me triple check. Oh, it's minus 13. This one, there's a lot of numbers that aren't prime, so I won't do 6x and x. It just doesn't feel right. I don't feel I can get that negative 13 because 6, yeah, it's just too big. So I'm going to do 2x and 3x. That gives me my 6x squared. Now I want to make negative 13 here. So maybe, oh yeah, 3 and 2 here. 3 and 2, because this will make, the outside terms will give me 4x, inside terms will give me 9x. 4x and 9x give me my negative 13. Bam, bam, done. Okay, so we have a few more factoring techniques and then we're done.